Check this out. Most students make mistake in these kind of questions, and it's not because they didn't study, but maybe they mixed up two colors. Look at this yellow turmeric. One drop of liquid and it turns red. No heat, no flame, just one drop of liquid. What do you think caused this particular thing? By the end of this video, you'll answer everything perfectly. Every part of it. No confusion. Every day in life, we deal with thousands of things. Some things taste sour, like say lime juice or maybe curd. You can even think about tamarind. These are acids. Some things, on the other hand, are slippery to touch. Say, for example, you can think about soap or baking soda. These are bitter. These substances are bases. But here is a problem. In science lab, you cannot touch everything or you cannot taste everything because it might be corrosive. It might burn your skin. So how do the scientists check whether the substance is acidic or basic? Well, they use something called as indicators. An indicator is a substance that changes its color when it comes in contact with acid or a base. And it is this color change that tells us whether the substance is acidic or basic. Now, there are three types of indicators: natural indicators, synthetic or artificial indicators, and third category is olfactory indicators. Now, the first one is natural indicators. You have already seen it, turmeric, at the start of the video. Turmeric is a natural indicator. It comes from a plant, Curcuma longa. That's the name of the plant. In an acidic solution, turmeric stays yellow, whereas in basic solution, it turns red. I'll repeat, for the exam purpose, in acidic solution, it stays yellow, whereas in basic solution, it turns red. The second natural indicator, and the most famous ones, of course, is litmus. Now, litmus comes from lichens. Lichens are small organisms that grow on the rocks or on the tree barks. So, litmus is a natural indicator. Now, litmus turns red in acidic solution and blue in basic solution. So, here is a hack to remember this. Litmus turns blue in basic. It turns B in B. That's so nice. So for exam purpose, litmus turns red in acidic condition and blue in basic. The second category is synthetic indicators. Synthetic indicators are not found naturally, so they are prepared in the laboratory. So there are two of them which we need to remember. One is phenolphthalein and the other one is methyl orange. So the first one, phenolphthalein, it remains colorless in acid, whereas it turns pink in base. For the purpose of exam, please remember, phenolphthalein remains colorless in acid and turns pink in base. Methyl orange, as the name suggests, is pale orange in color, but when you put it in acid, it will turn red, and when you put it in base, it's going to turn yellow. So for the exam purpose, remember the color change. Red in acid, yellow in base. Now here is something most students don't expect. There are certain substances which change their odor or smell depending upon the acidic or basic conditions, and these are called as olfactory indicators. Remember, these substances don't change their color, but they change their smell. Take onion for example. Onion has very strong smell in natural acidic environment, but in basic solution, the smell of onion disappears. This is because the base destroy the molecules that produces the smell in onion. Other olfactory indicators like vanilla essence or clove oil also behave in a same fashion. Alright, so let's bring everything together in a table. I'll put a table on the screen now. You can take the screenshot of this table. This is your cheat code for the exam. This will give you all the information regarding the indicators and their color changes. So, what about the red turmeric that we saw? Was that a magic? Or was that any kind of a trick? The answer is no. It was simply turmeric coming in contact with the base. In fact, that was the soap solution. So what about the question that we saw when we started this video? Let's try to solve it. So the question is, to the three solutions listed below, a few drops of phenolphthalein and blue litmus were added separately. Specify the color change in each case, if any. The three solutions that we have been given are sodium carbonate, which is basic solution. So it's very important to understand the nature of each of these solutions. Hydrochloric acid, as you can see, is acidic. And the third one is sodium chloride, which is a neutral solution. So sodium chloride is neither acidic nor basic, it is neutral. So what color changes will phenolphthalein and blue litmus show in each of these solutions? So as we have seen in the video, phenolphthalein will turn pink in basic solution, and there will not be any change in the color of phenolphthalein in acid because its original color is colorless. In case of blue litmus, it will not show any change in basic solution because it's already blue, and we have seen that litmus changes the color to blue in basic solution, and in acidic solution it will turn red. Both these solutions will not show any change in sodium chloride solution as it is a neutral solution. So this is the simple solution to this particular question. Very easy if you know how the indicators work. In the next video, we'll go deeper into the chapter and understand what makes certain substances behave like acid or base at the molecular level. If you like the video, please share the video with your classmates who are struggling with chemistry. Let's make chemistry much more easier. Thank you for watching the video. Also, please don't forget to subscribe the channel.